Antarctica is the continent of extremes. It's the coldest, windiest, driest, highest, least populated, and least polluted. It differs from other continents due to the absence of liquid water on a continental scale, the extensive cold and arid polar desert that leads to extreme environmental conditions, and the almost total lack of vegetation. It's a continent almost entirely covered by ice and snow, surrounded by the Southern Ocean. Its territory accounts for about 9% of the Earth's land area, making it the fifth largest continent by surface area, with a total area, including ice shelves, of 13.8 million square kilometers, much larger than Europe, 10.5 million square kilometers, and the United States of America, 9.4 million square kilometers. Antarctica is located almost entirely south of the 60th parallel, nearly central to the South Pole, and its coasts are about 950 kilometers from South America, 2,300 kilometers from Tasmania, 2,200 kilometers from New Zealand, and 3,600 kilometers from Africa. 98% of its surface is covered by an ice sheet, which contains nearly 70% of all the fresh water on our planet. The average thickness of the ice sheet, which conceals a terrain of mountains, valleys, and plains, is about 1,990 meters. In some places, especially in the interior, the thickness exceeds 4,000 meters, making the average elevation of this continent 2,300 meters, 3 times higher than that of other continents. The highest point on the continent is Vinson Massif, 4,892 meters above sea level, while the lowest point is the Bentley Subglacial Trench in Western Antarctica, at a depth of 2,538 meters. Antarctica has a subcircular appearance, its shape irregularized by the Antarctic Peninsula, which extends northward, and the two large indentations on opposite sides of the continent, the Weddell Sea and the Ross Sea. The polar ice cap reflects the features of the underlying terrain and is divided into two portions, the eastern and western ice caps. The fronts of these two ice caps, generated separately from the relief of the two Antarctic regions, converge at the foot of the Transantarctic Mountains, in the territory separating the Weddell Sea from the Ross Sea. The ocean surrounding the continent consists of the southernmost parts of the Atlantic, Indian, and Pacific Oceans. In the subantarctic region, between 50 and 60 degrees south latitude, there are many small islands. Some of them, like Australia's Heard Island, are almost entirely covered by glaciers, while others, like Macquarie Island, are ice-free and lack permanent snow cover. Despite ice covering about 98% of Antarctica's surface, there are approximately 250,000 square kilometers of exposed land, mainly concentrated in the large rocky outcrops found in the Antarctic Peninsula and the Transantarctic Mountains. Then there are the countless nunataks, small rocky outcrops of the highest mountain peaks that rise like rocks above the ice cap. The true boundary of the Antarctic region, the one that separates it like an insurmountable wall from the rest of the world and preserves its extreme characteristics, is an oceanographic boundary known as the Antarctic Convergence or Antarctic Polar Front. The Antarctic Convergence is a 40 kilometers wide area of sea surrounding Antarctica between 45 degrees and 60 degrees south and is traversed by an intense clockwise marine current. The transition between distinct bodies of water due to differences in temperature and other physico-chemical properties, probably formed 25 million years ago, is sufficient to create a barrier between the Antarctic Ocean and the other oceans, Atlantic, Pacific, and Indian. Since then, the strong circumpolar current has biologically and climatically isolated the new continent. When, during the same period, atmospheric carbon dioxide levels decreased, a permanent ice cap began to form so that about 15 million years ago, the continent must have appeared as it does today, almost entirely covered in ice with an average thickness of 2.4 kilometers. Well, that's all I could tell you about this extraordinary continent, but I bet there are still a couple of things you'd like to know. The first one is probably about the effects of global warming. How many years will it take for its entire icy blanket to melt? The second one, instead, is surely this: can it ever become a habitable continent again? Absolutely. Understandable curiosities, stemming from the fact that our mental attitude towards this hostile and unknown land is ultimately quite similar to what we have towards Mars or any other world. We perceive them as unreachable, but one day they could be ours. But to make predictions about the future changes of the Antarctic ice cap, It is necessary to know its past. Understand how all that ice accumulated, and above all, when? The history of Antarctic ice is complex and dynamic. Recent studies have shown that, despite apparent stability, the ice cap has undergone significant variations over millennia. Periods of ice accumulation have alternated with melting phases, influenced by natural cycles and, more recently, according to many, by the impact of human activities. If we wanted to imagine what Antarctica was like tens of millions of years ago, we could. Just look at how the forests of South America are today, humid and with mild temperatures. And even, the animals that inhabited it at that time were not so different from those we would find today. In the South American continent, beneath its icy surface lies a land that was once very different from what we know today. Using satellite data and radio echo sounding techniques, scientists have been able to outline the characteristics of this hidden landscape, revealing a topography shaped by rivers and lakes, with vast valleys and towering mountain ranges. Antarctica once had forests and rich terrestrial fauna, including marsupials, which probably expanded from South America through Antarctica and all the way to Australia. The average annual temperatures were around 12 degrees Celsius, and the sea level was 170 meters higher than today, just as were the CO2 levels. Things began to change when Antarctica separated from Australia about 53 million years ago, and then from South America with the opening of the Drake Passage about 30 million years ago. As with other continents, seafloor spreading in some places and subduction in others caused Antarctica's position to change over geological time. About 200 million years ago, the Antarctic continental crust joined with the South American, African, Indian, and Australian continental crusts, forming a large southern landmass known as Gondwana, the southern part of the supercontinent called Pangaea. After this period, Gondwana slowly split to create Antarctica as a separate continent, and Antarctica gradually moved away from the other southern continents towards its current polar position. Gondwana split. As the continent shifted to its current position, its climate changed in response to the greater seasonal differences in sunlight and the overall reduced level of solar input associated with higher latitudes. However, even when its position was close to today's, about 100 million years ago, it still had a much warmer climate than it does now. There is fossil evidence of forests that at various times reached as far as 85 degrees south. Therefore, Antarctica's position alone cannot explain its cold climate today. Instead, we must turn to factors that have altered the global climate from the Cretaceous period to the present. About 100 million years ago, for example, the concentration of carbon dioxide and other greenhouse gases was much higher than it is today, leading the planet to have a warmer atmosphere and preventing the accumulation of glaciers everywhere. Additionally, the structure of the land and sea near Antarctica was such that warm currents could penetrate into the high southern latitudes to moderate the polar climate. Studies of the continent's rock formations and sediment deposits on the seabed indicate that Antarctic glaciers began to form in favorable positions during the late Eocene, perhaps 38 million years ago. However, even 14 million years ago, fossils of tundra vegetation recently discovered in the dry valleys of McMurdo show that the climate was similar to that of the southern tip of South America today. Shortly thereafter, Antarctica cooled further, and the East Antarctic ice sheet reached similar sizes to those of today about 13.8 million years ago. Two important tectonic events also explain the cooling of Antarctica: the widening of the sea between Antarctica and Australia and the division between South America and the Antarctic Peninsula. These changes in the land/sea configuration were crucial for the establishment of the cold circumpolar current that circulates clockwise around the continent, preventing warm water from reaching the coast. Once the ice began to spread in Antarctica, the process was reinforced through positive feedback mechanisms. With more ice, there was greater reflection of sunlight into space, higher albedo, which acted to further cool the continent's surface temperature. Today, with the increase in carbon dioxide in the air, most climatologists, supported by the media, always desperately seeking catastrophic narrative angles, instead tell us that, what if all Antarctica's ice disappear? The ice is retreating and that, even worse, there is a danger of complete melting soon. But do we know what Antarctica would look like if all the ice were to disappear?